All right, we're gonna. I don't know if we'll finish it or not, but at least we'll continue with 1-3. And this whole thing was called Exponents. So that was the title. All right, so the last thing we did was the power rule. Since it was the last thing we did, we'll just start from there. Power rule for exponents. Let's see. So what if we did this? I don't know if we wrote this down yesterday or not. Did we write this down?
Yeah.
Did we? Okay. So if you have this, if you have a base, let's everybody pay attention. Let's everybody face the front. Let's everybody stop the conversations. Let's pay attention. Let's just watch. Okay, so here we go. So here's the first rule for the power rule for exponents. We'll give you some examples here in a minute. All right, let's just write them down right now. So if you have something like this, if you have an exponent being taken to another power, so if you have this in parentheses to another power, okay, the power rule says that you multiply those exponents together. So it would be x to the mn, right? And we'll do an example. Well, let's do an example right now. So what if I had x to the third, and that was to the fourth power? Okay, so what does that mean? This means it's x to the, what do we do with the exponents now? We multiply them, so that's x to the 12th. Shame, it doesn't help. So this is x to the 12th. Okay, why? Because the power rule says when you have an exponent being taken to another power, we multiply those exponents together. All right, so that's a quick little example of that. Sometimes you might have something that looks like this. All right, so if you have something that looks like this, that means we take everything in here to that power. So everything in here is being taken to the nth power. So how do you think we would write that? X to the what? No? Everything in there is being taken to the nth power. So you take x to the nth power, and then you take y to the nth power. That's what that means.
Is that M or N?
It's an N. I keep saying it. I said it over and over again. I said it's an N. Shh. Shh. Let's do one with division. It's basically the same. Well, it's not basically. Yeah, it is. It's basically the same thing as this, except it's N. And then this is also to the n power. So if something's being divided and it's in parentheses and everything's to the n power, that means we take everything in here to the n power. And then we do what it tells us to do. It's division. Right here it's multiplication, so we multiply those together. This is division. So really it's the same thing as this, except instead of multiplication, it's division. So we write x to the n over y to the n. And that's how we would write something like that. So let's do a quick example of this. So what if I had that's good enough for that. Let's move on to the actual examples that the book gives us. So this is example 3 on section 1-3, if you're following along in the book. They give you a bunch of them. So I'm going to write them down, just like we did yesterday. I'm going to write them down. I want you to write them down, and I want you to come up with an answer to these, all right? I don't think we did these. No, I don't think we did these yesterday. So it's 3 squared cubed equals, so that's A. Part B is x to the 11th, in parentheses, to the 5th. So it says simplify each expression. That's what the instructions say. Let's everybody do this. Let's everybody work. So if you're working, got another one. X squared, x cubed. That's to the 6th. And then D is x squared to the 4th. X cubed squared. All right, all these say to simplify each expression. I'll just say simplify. Just trying to come up with what the simplified version of these things are. All right, we just went over the rules. So if you need to look at the rule, go ahead and come up with an answer. Give you a minute. Now on this one, you might have to use a calculator on this one to get the simplified answer. All the other ones should be able to do without a calculator. Everybody trying these? Nico, you trying these? Did you write them all down? You finished them? Okay. I asked you to write them down. You should be doing this in your notes. Shane, stop. You should be doing these in your notes. You should be writing them down. You should have written down, and then you should have an answer right next to them. Everybody, if I walked around, everybody should have something right next to these. All right, minutes up. So here we go. We have an exponent to another power. So we use the power rule. That's the rule that we're working on right now. So what is the rule? What does the rule say? We keep the base the same, and what do we do with these? Multiply them together. So it's just what? 3 to the 6. This is the part that I said you might need a calculator.
I got 729.
If you just keep it like that, for right now I'm fine. But if you use a calculator, Shane's right, it's 729. Okay? So it's 3 to the 6th. All right, this is your base. This 3 is your base. It kind of acts like the x does in all the other problems, right? But it's a number. The base is actually a number. But what do we do with the exponents? You multiply the exponents together. All right? Right here, this is even easier. Same rule. It's an exponent taken to another power, so you keep the base the same. What do we do with the exponents? Multiply them together. So x to the 55th. That's how you do that one. Now this one's a little bit different. So it's like a two-stepper. All right? You could, if you wanted to, you could go x squared to the 6th, right? And what would you get? X to the what? 12. Then you could go times x cubed to the 6th. What would that be? X to the 18th. So then you could go x to the 12th times x to the 18th. What would you do with the exponents in that situation? If you're multiplying, you would add them. So it would be x to the what? 30th, okay? An easier way to do it would just be simplify the stuff in the parentheses first, okay? And then go ahead and take it to the 6th. That's what I would do. That's what I would suggest that you do, okay? That's why I didn't write any of the other stuff down. Okay, that's why I'm just keeping it like this. So x squared times x cubed is x to the what? 5th. Why didn't I multiply the 2 and the 3 together? I've been multiplying here and here. Yeah, it's not necessarily because it's in parentheses, but it's because they are being multiplied together, okay? We had a rule. It was the product rule for exponents, I think it was called, right? So you multiply them together. When you multiply these together, what do you do with the exponents? You add the exponents. That's why we added them to get the 5. Now, this x to the 5th, not just by itself, it's what? It's to the 6th power. Now, this is a little different than what we just did here. So x to the 5th to the 6th is x to the 30th. It's the same rule that we applied right here and here. Okay? So that's what that would be. Everybody with me? It's pretty simple if you just know the rules. Okay, really, people struggle and struggle. People struggle with exponents because they don't learn the basic rules, okay? Like I said yesterday, you may already know how to do this stuff. You may remember it, but I'm teaching you as if you've never seen this before. All right? So I'm not, making any assumptions about your prior knowledge of this stuff. All right? So everything that I've taught yesterday and today should be good enough to do these problems right now, even if you've never seen it before. Okay? What are we going to do here? Well, I would break it down. I would just do this, get an answer. Then I would do this and get an answer. Everybody with me on that? So what's this going to be? X squared to the 4th. X to the 8th power. You should know, okay? I don't know is not a good response because we've just finished talking about this many times here. So when you have an exponent to another power, you multiply the exponents together. Same thing here. You got a base, which is x, and you got an exponent to another power. It's the power rule, so you multiply them together. It's to the 6. Now, you multiply these together. If there's no dot, that means you automatically multiply them together. Okay, I'll just put a dot right there. They're multiplied together. So the rule is it's the product rule. So you keep the base the same, and you add the exponents in this situation. 8 and 6 is 14. So that is x to the 14. We good? Let's do some more examples. And then we'll do a little bit more after this. So example 4. Let's just stick with me. Right. I said I wasn't going to collect the homework today. First, because I didn't hand out the homework to you. Some of you had a book, some of you had it online. You were able to do it, but that's the first reason why I'm not collecting it. Second is I haven't taught all this stuff yet, so I want to teach some more. So just hang on to your homework. Don't worry about it. Let's just stick with what I'm doing right here. Okay, write this down. X squared y cubed. All right? Shouldn't be too hard. Part B, kind of the same thing. Just gives you a few chances to practice. That's to the 4th. Then C. Now we're going to throw in a fraction. This is to the 4th. And part D, another fraction. X cubed over y to the 4th. And that's squared. That whole thing is squared. There you go. All right, there it is. Work them out. Write them down. Don't just look at them and say, oh, I just did them in my head. I want you to write them down. I want you to actually put them in your notes. This is all part of your notes. So everybody should be working. Stop the whistling. Give you 30 more seconds. Just because you're finished doesn't mean it's time to talk. Let's face the front. Let's face the front. I heard it. I'm sure there's teachers out there. All right, let's do these. Here we go. So this is a little different. You can't really simplify this stuff in the parentheses right now, can you? Because you got an x and a y. So basically all you're doing is taking everything in here to the what?
Right.
To the 3rd power. All right, so what's this going to be? X squared cubed.
6.
X to the 6. It's not just 6, it's x to the 6. And then this is going to be what? Y. It's not just a y. Everything in here is being taken to the 3rd power. So we got to take this to the 3rd power, so it's y cubed. That's it. See, if you wanted to do a secondary step, you could have gone this. You could have gone y squared cubed, then you could have gone y cubed. That's what you're doing, right? You're taking everything in there and cubing it. But I think you could do this part in your head, all right, and then just write that down. So this is definitely something. There's really not. I mean, I guess you could share your work right here, but I don't think this is really necessary. All right, here we go. Let's look at this. So what's this going to be? This is going to be x what?
3 plus 4.
Is it plus 4?
Yeah.
Is it?
Yeah.
What's the rule? What's the rule? Come on. We've been doing this for 15 minutes. Right, so we can't do anything in here. So what do we do with this? Right, that's right. It's 3 times 4 because they got an exponent being taken to another power. So it's x to the 12th. It's 3 times 4. What's the y going to be? Y to the 16th. Okay. Are we getting this or not? I don't know. I'm not getting really the answers that I'm looking for here. This is x to the 3rd to the 4th. You means you multiply the exponents. Y to the 4th to the 4th means you multiply the exponents.
I did what I did before and added the.
Yeah, but you can't do that because they're different bases. All right. This is the same idea. Looks a little more difficult, but it's not. It's just because it's a division. You do the same thing. So you take everything inside that parentheses and take it to the 4th power. So you take what? X to the 4th. Now, if that's on top, if that x is on the top, we keep the x to the 4th on top. Then on the bottom is y squared to the 4th again. So what's that going to be? Y to the 8th. It's pretty simple, right? It's just basic multiplication. But you got to know when to multiply and when to add, right? That's the key. It's just when to do it. Actually doing it, it's not difficult. It's pretty simple stuff. It's when you do it, right? Right here, we don't add the exponents at all on any of these, do we? Right? So what do we got here? We got x to the 6th over y to the 8th. Simple. Just like that. All right? We good? All right. Let's keep going. What if you had something to the 0 power? X to the 0 power. It's 1. It's exactly 1. And it doesn't matter. Since this is an x, it doesn't matter. What? I love that answer. It just went up. Yeah. What? What do you think? What do you think? I'm talking, you're talking. You say what when I look at you? You know. You know what? You know what? That's all I got to say. Anything to the 0 power is a 1. What if I had 3 to the 0? What's that? It's 1. What if I had 547 to the 0 power? What's that equal to? It's equal to the number 1. All right? A lot of people get this mixed up. I had a lot of people do this last year. I had x to the 0, and they say that's 1x. Is it 1x? No, it's just the number what? 1. It's just 1. Okay? It's just the number 1. I'll show you. Well, we got to do something else before I can show you why that works. Okay? I got to talk about negative exponents before I show you why this works. Okay? So remind me. I think it's kind of interesting. But, you know, I'm a nerd, so whatever. Oh, what if you had something like this? What if you had something like this? X, z to the 3rd. What's that all equal? Why? It's all being taken to the 0 power. It doesn't matter what you have in here. You can have the craziest things in here. If it's in parentheses and to the 0 power, it's always a 1. Okay? All right. I think we beat that horse enough, didn't we? All right. Now, let's talk about, I just mentioned it, what? Negative what? Exponents. Okay? This is where people start freaking out. All right? So, if it seems super easy before, because you've had it all before, I'd still pay attention to this. All right? Because this part right here can, it's not difficult, but it is a little different. It's the one thing that my experience teaching students that they have a difficult time with. All right, so I'm just going to give you, I'll write down a few things that the book says, and then we'll go from there. Then we'll do some examples. All right, so a negative exponent would be something like that. All right, so there's an exponent, which is n, and the exponent is now negative. All right, so that's that. I'm going to do something right here. This is where I'm going to show you that x to the 0 is equal to 1. All right. So watch this. Well, actually, do you have any control over just talking out? It'd be nice if you just showed a little control over that. Because we've talked several times today about that. All right, what if you had this? What's the rule? What's the rule when you're multiplying things with the same base? What do you do with the exponents? It's add. It's add. Okay? But you add. I mean, if you add a negative, yeah, technically it's subtraction. But it's addition, right? So you add the exponents. So what would this be? I keep the base the same, right? And then I do that. Right? Because negative n plus n, negative any number plus the positive version of that number is always what? 0. So what is that equal to? It's equal to 1, isn't it? All right? So what if I had this? Let's put actual numbers in here. What if I had this? What's that equal to?
0.
Is it?
I was about to say what.
What do you want to say? He's allowed to. Chris. I mean, sorry. Shane. Just pay attention up here. Is it x to the 1? What did we just do up top? Yeah, it would be x to the 0. And what's x to the 0? It's 1. Right. So you doubted yourself. Don't doubt yourself. So here you go. The reason I'm showing you this is this. Let me show you something. Well, they're really not, what they're doing right here is really not. Let me just show you this. I'm trying to figure out the best way to go. So this is basically what a negative exponent means. So if you have x to the negative n, it's the same thing as 1 over x to the positive n. So that's what you need to know about negative exponents right there. I'll explain it to you a little bit, but write it down. Okay, it'll make sense in a little bit. Here's another thing they could do. Let's see if you can follow this. What if I had 1 over x to the negative n? What do you think that's equal to? Look at this, and then look at this. What do you think that's going to be? 0? Thought you had your hand up. I'll just tell you. It's x to the n. It's x to the n. It's not xn. All right? Now, it seems like I'm being really picky, and I am, for good reason. So it's not xn. Xn means something completely different than x to the n power. All right? So I'm going to show you how this stuff works. I think you'll understand it better when I start doing some examples, okay? So let's do some examples. So if I had something like this, if I had x to the negative 3 power, and I asked you to write that without a negative exponent. Okay, write it so it doesn't have a negative exponent. Say it. Very good. It's 1 over x to the what? Positive third. Okay? What if I had something like this? And again, I'm making this super basic. I'm making it look just like the stuff in the boxes, except I actually have a number for my exponent instead of an n. What if I had this? X to the 1 over x to the negative third. What's that equal to? It's x to the what? Third. Okay, it follows that exactly, doesn't it? Okay. Let me show you a way. It's not really a trick, but it's a way that I can remember how to do this. I don't really memorize these two things right here. What I do is this. Everybody watching? Sorry to interrupt your conversation, but if I put that over 1, you could put anything over 1, can't you? Right? Anything. And it's still equal to what it originally was. All right? Here's how I think of it. I think of it like this. Whenever you see a negative exponent, what you can do is you take that negative exponent with that base, and what you do, you can chuck it down to the other side. So if this is on top, where are we going to throw it? Down to the bottom. But when we throw it down to the bottom, we got to change something. If we move it, we can't just keep it exactly the same. We got to change it. So what do you think we're going to change? The negative to the exponent. Okay, we're going to change the sign to the exponent. So if I take it and flip it to the bottom, then I'm going to make it x to the what? Positive third. So I moved it from the top, I moved it to the bottom. Everybody see that? So if it was negative exponent, if I move it to the bottom, then it's a positive exponent. What's left on top, though? Not just nothing? No, not a 0, because 0 over anything is 0. It's a 1. There's a 1 right there. So what would this be equal to? 1 over what? X cubed. We'll do some more. Just hang on. What if I wanted to change that and I didn't want that to be a negative exponent?
Remove it to the top.
I'll do some more.
No.
What? What do you need? I can't speak in sentences. Okay, that's great. Just concentrate on what I'm doing. All right? Don't worry about other people. My word. So I got x to the negative third. How do I get rid of that negative? I chuck it up to the top. I flip it and then change it to a what? A positive. All right? So it goes away there. And then what do I got? 1 times x cubed, which is x cubed. Everybody see that? Now they're going to get a lot more complicated than that. Let me do a couple examples. Let's go back to white. They don't really give you these examples. I'm going to make some examples up. This is my example. So what if I had this? What if I had x squared times y to the negative third, and then I had x to the negative fourth, y to the fifth. Okay, what if I ask you to simplify this and write it so that there's no negative exponents? Okay, simplify it and write it so that there's no negative exponents. All right, so where do we look? Well, let's do this first. Let's find the negative exponents and make them positive exponents. So which one do you want to do? The top one? Let's do the top one. So let's take that. It's a negative exponent. How do I make it so it's not a negative exponent? Flip it down to the bottom. So I'm going to flip it down to the bottom, but I got to do what to it? I got to change it to a positive exponent. All right? If I flip it, I got to change the sign of the exponent. I can do one more. What else can I do? That's right. Take the x to the negative fourth, flip it up, and what's that going to make it? X to the what? Positive fourth. Everybody see that? Okay, let's rewrite it so it looks nice and neat without all the circles and stuff crossed out and all that kind of stuff. Okay, so what do we got on? Actually, we can just figure it out. Let's just figure it out. We got this on top. So what's that going to give us on top? X to the sixth. Okay, over what? Y to the eighth. And there you go. You could. Okay, I'm going to show you that in a second. Okay, now you could, but I'm telling you what I think is a little easier. I think it's easier if you have a negative exponent to just flip it. Okay, now we have a rule. This is the last rule we're going to do. We only got a minute left, so watch. It's called the quotient rule. What does quotient mean? It means divide. Well, the question I asked you was to make them so they're not negative. All right? So I asked you to simplify it and not have any negative exponents. Okay? Let's look at this rule. This rule right here says you're dividing with exponents. So before, when we multiplied with exponents, we would add them. What do you think we're going to do when we divide with exponents? We're going to do what to the exponents? No, it's divide. I said when you multiply, you add the exponents. So when you divide, what do you think? Subtract the exponents from each other. So that's a rule right there. So that's that rule. So let me do one example and then we'll quit. Let's do that same example as we did up here. Bell's going to ring in a second, but let's just stick around for just another minute after the bell rings. So watch. You've got this, and then you had x to the, what, negative fourth, and you got y to the fifth. Now watch very carefully. I said stick around until I finish this. So have a seat. Stick around until I finish this. So with this quotient rule, what could you do with the x's? You could do what? X to the what? What do we do with the x? This is division, so what do? We subtract it. Is it 2 minus 4? No. It's 2 minus what? Negative 4. And then it's y, negative 3 minus 5. Now look what we get. This is going to be x to the what? 6. And this is going to be y to the negative 8. But if we make it so there's no negative exponents, we're going to take this, we're going to flip it to the bottom and make it, make it y to the 8th. You still get the same exact answer. But this is where students have a lot of trouble. All right, and this is where they make a lot of mistakes. So this right here is the method that I would use to solve a problem like this.
Good job, guys.